Thank you for joining today's session, Predictive in 20 Minutes. My name is Joe Mahoney, Client Technical Professional for IBM SPSS. We'll get started with a few slides and then get right into the exercise. So let's talk about the purpose of today's session. We want to introduce you to predictive analytics and data mining. We'd like to stimulate thinking about how data mining would benefit your organization. So we've got a specific use case that we'll be using today. It's customer churn, and by churn I mean turnover. We have a theoretical telecommunications company who wants to look at their customers and find out who's likely to churn and why. But along the lines of that, I'd invite you to stimulate your thinking to broaden out past not only churn, but to other potential use cases. Think marketing response, or who's likely to buy something, or who are my best employees, who are my best customers, etc. We're going to demonstrate the ease of use of powerful technology. So make no mistake about it, the techniques in here, these are advanced analytics and data mining. What IBM SPSS Modeler does is it brings this advanced technology into the hands of the business user, and through very easy to use and point and click interfaces allows the business user to grasp and get a handle on these advanced analytics techniques. And finally, we will demonstrate and discuss how this leads to more informed decision and real ROI for your organization, because predictive analytics is one thing, but if we don't use it to make more informed decisions, then it is not as useful as it possibly could be. So it's very important to stress that at the end, we're going to make more informed decisions by using predictive analytics. So what is predictive analytics? Well, the Gartner Group describes it as predictive analytics helps connect data to effective action by drawing reliable conclusions about current conditions and future events. I have my own definition as well that I'll give. It's the idea of taking a look at historical data, things that already happened. And for the majority of our workshop today, or of our exercise, we'll be looking at historical data. We're going to use modeling techniques to uncover patterns and relationships, some obvious, some not so obvious, but we're going to uncover patterns and relationships in this historical data. We're then going to package up those patterns and relationships, and we're going to apply that to new data for which we don't know what the outcome is. And then we can make real predictions that will, again, lead to more informed decisions. So what are some areas for predictive analytics? First off, in the upper left, we've got customer analytics. Who are my best customers? What are they likely to buy? Why are they likely to buy? When are they likely to buy? Fraud detection and prevention. Think the financial world and insurance. What debit card transactions are likely to be fraudulent? Which insurance claims are likely to be fraudulent? Industrial process optimization. Think predictive maintenance, and think of the IBM commercials that we see these days with these large industrial machines. All of these machines these days, and now more than ever, are outputting tons of information and tons of data. There's gold in that data if it is mined properly. Human capital management, very similar to customer analytics, but working with arguably an organization's most important asset, their employees. So who are my best employees, and how do I find more like them, so on and so forth. Crime analysis, crime prediction and prevention, and we work in science as well, and many more. So let's talk about the packaging. Well, we'll be working mainly off of the desktop today. Modeler is also offering a couple different flavors. So for example, we can add server functionality on the back end behind the scenes to significantly increase processing. We can also add on some complementary products such as IBM SPSS Collaboration and Deployment Services, and we can also add in decision management. These add functionality like real-time scoring, and then decision management says we can combine powerful output from a predictive model, combine that with business rules, and also put in an intervention. So think of insurance. I can use all these products combined to say the predictive model says this insurance claim is likely fraudulent. My business rule says that the claim is over $200. My intervention says send it to Special Investigations Unit. IBM can handle that entire workflow from beginning to end. We also have two different flavors of the product itself. So we have Modeler Professional, think all quantitative analysis, and then we have Modeler Premium, which adds in some text analytics and text mining. We also add in entity analytics to resolve like entities. Think 3 people in your database that may or may not be all the same person. Entity analytics looks at the data around the data to get a confidence score if they in fact are the same person. Finally, social network analysis has to do with not social media, but social network. So who's an influencer in this social network? And we can target those influencers different than we would target non-influencers. And finally, let's get into the demonstration. Let's start with the end. We can take this key insight from the model and we can output it to something like business intelligence. So what we're looking at now is IBM SPSS Cognos Business Intelligence. Talked about uncovering patterns in relationships, some obvious, some not obvious. Well, the predictive modeling technique has identified that, let's see here, marital status and payment method, among others, are some of our key predictors to this customer churn use case that we're focusing on, so that we can then visualize these key predictors in a dashboard form to make this output consumable by anybody. As you can see, this is a browser here, so this can be accessed through a browser anywhere. We can push this output out to a mobile device, really anywhere, and that's really powerful. And then finally, we can also use BI to make decisions. So what we're looking at now is a list of customers that are likely to leave us. So I can access this list on the fly. I can put my intervention in place based on my business, for example, maybe make phone calls out to those at-risk customers to just see how they're doing in order to keep them around. That's where we make those decisions based off of our predictive output. So with that, let's get into the product demonstration. And let's start with an empty canvas. So what we're looking at here is IBM SPSS Modeler. Let's start by giving a lay of the land. There's a theme as I will go through this presentation, and that theme is working from left to right. So if you draw your attention to the bottom of the screen, I've got a number of tabs from sources all the way down to output and export. So as we read this from left to right, sources stands for our data sources. So what I can do is I can start on the left in my sources tab and just drag some of these nodes. We call these nodes up onto the canvas, and I'll zoom in here so we can see a little bit better. But as I work from left to right, we'd start by dragging data sources. Modeler is very good at working with disparate data sources. So for example, I could have some point of sale data sitting in a database somewhere, connect to that through an ODBC connection. But then I might have some of my survey data sitting in an Excel file, or maybe an SPSS.sav file, or maybe IBM's own survey research software, IBM SPSS Data Collection. All of these disparate data sources can be pulled in at the same time. Then as we work from left to right, we've got record ops and field ops. Modeler is also a full data management manipulation tool. So if I need to do something like derive a new variable or do some data preparation or any kind of management manipulation happens in these tabs. Graphs is visualization, so we have some data exploration through visualization capabilities as well, on top of pushing out to some classic business intelligence. Our modeling tab is just that. It's all the different modeling techniques. Last I counted, I think there's 28 different modeling techniques. Finally, output and export. This is where we send our output somewhere in order to make more informed decisions. So more on that as we move on with the presentation. So looking up and drawing your attention to the canvas itself now, there's also a theme from left to right here as well. So before we get into the exercise, let's talk about the concept of a stream. We read a stream from left to right as well. So for my data sources tab, I dragged up an Excel file. Every time we drag up a new node onto the canvas, we're going to double click on it to edit it. So for example here, if I double click on Excel, I get a menu, a point and click menu that's going to say, okay, you want to work with an Excel file, tell me where it is. So I'll click on this icon here, and I will point to my data file in my predictive in 20 minutes folder. It's called customers.xls. So we have a nice feature in a lot of these nodes as well. Those of us who have worked with Excel before know that it's not always perfectly stored. Sometimes our variable names aren't across the top. So we've got this preview button that I can click that's going to pull in just the first 10 rows of data. Because if I'm working with a couple thousand rows, even a million rows of data, I might not want to pull all of that in until I'm sure it's going to come in right. So in this situation, I hit the preview, we've got 10 rows of data. Let's use this to frame up our use case. We're a fictional telecommunications company. We want to find patterns and relationships in customers that have historically left us in order to predict if current customers are going to leave us or not. So we have this variable in here called churn. It says canceled or current. This already happened. We already know that these customers left. Then we also have some demographics, number of children in the household, household income, and then we have some usage variables as well, drop calls, number of minutes, etc., etc. So the concept of the stream is we read this from left to right. So I've dragged my data source up onto the canvas. Now I can click on my Output tab and just drag what's called a table node. I'm going to visualize this data in row and column format. So I connected this. So we see this arrow going from left to right now. If I run this output, really quickly I created a very simple and very basic modeler stream. We pulled in some data, and then I executed some output in the form of a table. So with that, let's get into the actual predictive exercise. You can go back to customers.xls. So here I'm going to go into my field ops, and we're going to drag up the all-important type node. The type node does what's called instantiating our data. So if I double click on this, we get this screen. For those of you who have used SPSS statistics in the past, this is going to look very similar to the variable view. So what I'll do in here is I'll click read values. It's going to do a good job of doing a first iteration of looking through our data, defining the unit of measurement, defining its values, and then we're also going to work with role, which is very important. So role is how any analytics that we do downstream is going to deal with the data. So for example, I'll change churn, again that's historically telling us if these customers have stayed or left, change that to my target variable. In statistics speak, we're saying this is now my dependent variable. I'll change record ID to record ID because we're not going to find any patterns or relationships in customer IDs. So the way that we read this now is everything that's marked as an input is we're going to have modeling techniques look for patterns and relationships in each of these inputs as they're related to customers churning. We can also change the unit of measurement as well. So I'll click OK here and let's move forward. Let's click on our Graphs tab and do a very quick and simple visualization. I drag a distribution plot up onto the canvas and connect that up from left to right. So now we've brought in our data, we've instantiated our data, and I'm going to create a visualization. So I double click on it to do my visualization, and it's going to ask me what would you like to visualize. Let's take a look at historical customer churn. So I'll select that as my field and click Run. And really quickly I just get a nice exploratory visualization of my historical customers, who's left and who stayed with us. Next we'll click on our modeling tab. Well, we're going to use a specific modeling technique. In this demonstration, it's important to point out these automated nodes. These are customer fan favorites. So if I drag this auto classifier up and connect it, first off, it already knows that we're looking at churn because this is downstream. This box that I just highlighted is downstream. So the fact that I identified churn as my target variable in this type node, downstream, my modeling techniques now know that that's what I'm looking at. So if I double click here and click on the Expert tab, I just want to point this out real quick. Most organizations who have taken the dive into advanced analytics might be doing something like a regression or a logistic regression. And why? Because it's always been done that way. But what if another modeling technique might be better as applied to my data? These automated techniques will run each of these modeling techniques through my data independently and rank what the best ones are. So for example, maybe I don't have any experience with a Bayesian network, but it's the best at giving me my predictions. The software will take care of all of that for you and list out the top 3. Just wanted to point that out, but in this situation, in this example, we're going to use what's called the CNR tree, commonly referred to as a cart. It's a decision tree method. So while we're going to keep the defaults, and the defaults can typically give us some really good output. For anybody in the audience who might be more advanced and have some more experience in data mining, we have a number of different user-defined options within our modeling nodes to get more specific and more advanced with how we want to build out this decision tree. But we'll keep the defaults for now, and I'll click Run. So what this is doing is it's digging through the data, using this technique to uncover those patterns and relationships. That's what this hexagon does. It then produces this golden nugget. That is the model itself. So if I double click on this, that's all of those patterns and relationships that were just uncovered, packaged together into one nice model. So first off, we get what's called predictor importance. So this runs and it tells us of our data what variables are going to be the most important in predicting our use case or our target, in this case customer churn. So it looks like marital status, number of children, international minutes, etc. Then let's go through and actually read this decision tree. Decision trees are very good from a research perspective because remember, this is historical data. We're just digging into the why these people left. Decision trees are a very visually appealing way to look into those insights that the modeling's uncovered. And they're very good also at helping us to decide what interventions we can put in place when we eventually make real predictions. So let's walk through how to read this. At the top of the tree, we're looking at our base data set. So of our entire data set, looks like about 61.7% of customers have stayed with us historically, and 38% of this historical data set have churned. The decision tree technique says that number of children, looking here, using statistical confidence, is the most significant variable that's affecting churn. So if we bring the tree down a little bit and look at the next level, you can see here that if they have less than or equal to one child in the household, then our churners went up from 38% to 52.7%. Then the technique says that next to children, number of international minutes is the second most important predictor for this segment. So if we look down another level, we can see that if you had more than 14 international minutes of talk time, that number jumped up for churners from 52.7% to 71.8%. So we call this supervised segmentation. We've now uncovered a key segment of customers that are likely to leave. So the way that I would read this is once we apply this insight to new data and make real predictions, those in this segment with over 14 minutes of international talk time and less than or equal to one child in the household, I might want to offer them not a family plan, but more of like an international calling plan, something like that in an effort to keep them around. So now that we've created this model, what it does is it appends two new but very important fields to our data set. If we look all the way over to the right here, we have this new $R and $RC. $R is the model's prediction on what it thinks should have historically happened or would have historically happened. The $RC is its confidence in that prediction. So because we're looking at historical data, we're going to combine or we're going to compare this churn variable because this actually happened. We're going to compare that against what the model thinks should have happened. So to do that, under my Output tab, I have my Analysis node. If I run that, this tells us that based off using this historical data, our model matched up to what actually happened 83% of the time. So this would be an iterative process in of itself. I would work with these record ops and field ops to massage, to clean my data, maybe use something like the auto data prep upstream here until this analysis node is accurate enough for me to put this model into production. Once that happens, we'll apply this to new data. So then we'll look at this solution. And let's walk through what's happening here. We're working with a new data file now called newcases.sav. If I preview this, we have every variable available to us that we just worked with, except we're missing one key variable this time, churn. These are current customers. We don't know if they're going to leave us or not. We're going to apply those insights that we uncovered off the historical data to current customers in order to make real predictions and ultimately decisions. So let's move forward down this stream, and most of this is going to look familiar now. I've got my type node to instantiate the data, but again, we're missing that churn variable here. We have everything else. This is a literal copy and paste of that model that we created in the previous exercise we just did. This is packaging those insights and those relationships up. We're now applying it to new data. So if I preview this, these fields that the model appends, the $, are now very important because these are real predictions on real current data. So now that we have these predictions appended to our data, I've generated what's called a select node. So this is saying I want to select out only those customers that are predicted to leave. This is called a sort node, but all of these are found in record ops and field ops. This sort node says that I want to sort in descending order the model's confidence in that prediction. So select out just those likely to leave and sort those from most confident to least confident in that prediction. Finally, we'll drag in our sample node. This is saying that now that we've picked out just those likely to leave and ranked them in confidence, we're going to say, give me the top 50 or the first 50 records in my data set. And after we've done that sorting, it's going to be the top 50 records with the highest confidence score in their likelihood to churn. Finally, we can send that out to a number of different data sources. So maybe you're using your organization's own tools for business intelligence. Well, we can write this right back out to a database table to be picked up somewhere else to make decisions. We have integration right with IBM Cognos Business Intelligence to do that. Or just right from the desktop, we can send out a flat file. We can send to a database table from the desktop as well. However, if we send this out to an Excel file, here's what we'll ultimately get. And here we're looking at the top 50 people likely to churn and their confidence in that prediction. So now I can email this list off to someone to make decisions on. Not someone who has necessarily a strong data mining and analytics background, someone who would actually be putting the intervention in place. So here you go, customer assurance or customer quality and care line of business. Here's your list of your top at-risk customers that you're going to want to make a phone call to make sure that they stick around because they're at high risk of leaving. So that concludes today's presentation of Predictive in 20 minutes. I sure hope that you found it helpful, and thank you very much for attending. Let's now open up just a few minutes for questions. So Anthony asks, what output would I use to utilize this churn model in real time? So that's a very good question. Looking at the desktop, I would click on this and I would click this run button to send it into, send those predictions out to my database or my Excel file or whatnot. But that's not in real time, right? So we certainly have the ability to deploy this in real time. We do that through what's called IBM SPSS Collaboration and Deployment Services. So I click on Deployment Type Scoring Only, I pick my model, and I go down and fill the rest of this out. That stores my model in a repository up on a server. Therefore, say I'm using a web portal, I'm a telecommunications company, and a customer calls me up to complain about something. Well, right in my portal, I can get a real-time risk score based off of their complaints. So I submit some information back to the model, which works behind the scenes, gives me a prediction on if that customer is likely to leave and what intervention I should put in place. I hope that answers the question. Thanks, Anthony. How does text analysis work? From Lynn asks. So text analysis works in a very similar fashion to what we just did. So if I open up a new stream and we look at this other example, what we'll look at here is the exercise that we just did. Up here is the exercise we just did. Down here, we're merging together and adding in customer comments from a call center. So if I look at this model, looks like if they mention their phone battery, well, that's now a key predictor to churn as well. So we've now included text. Text analytics we could take a whole day talking about it, so I wanted to just touch on it for the time allotted here. Happy to talk further if you want to get in touch with your sales rep. One last question. Edward asked if there's local workshops in Dallas, Texas to learn how to use Modeler. If so, who can be contacted? We certainly do visit Dallas for our data mining workshops. I'd urge you to go to IBM.com and just search IBM SPSS Data Mining Workshop to find a workshop coming to town near you. That concludes the session, and thank you again very much for attending.